Is this sharing? And yes, it is. Okay, good. Let me keep going. Okay, so that was right triangles. So I really don't want to get, I don't want to really go much further. I don't want to go more into right triangles than that. So what we're going to do now is look at circles, okay? So, you know, you have seen circles before, I'm sure. By definition, if you have a fixed point, okay, you get a circle. Namely, a circle is all the points that are the same distance from that fixed point. That's just what a circle is by definition. It's all points that are the same distance from that fixed point. I mean, what is that distance? That's up to you. You can choose. And for each distance, you get a different circle. Okay, so again, that's what I'm trying to show here. So if you have a fixed point and you have a certain distance in mind, whatever it is, 1 meter, 1 mile, whatever, the circle, you get a circle because it's all points that are the same distance, equidistant from that fixed point. That fixed point is what we call the center of the circle. The radius is that distance. So all points on the circle, okay, they're the same distance from that fixed point, and that distance is the radius. Also, visually, the radius is the length of the line segment with endpoints at the center and any other point on the circle. Endpoints at the center and any other point on the circle. So this is a radius. This is also the radius. Because again, they're the same distance. That's what a circle is. And there's some other terminology with circles that's good to know. I just said what the radius is. There's also the notion of the diameter. The diameter is twice the radius. Okay, it's twice the radius. And again, and visually, it's the length of the line segment with endpoints being points on the circle, and it has to pass through the center. So visually, the diameter is the line segment that passes through the center, and endpoints are points on the circle. This is one kind of diameter you can have, for instance. And remember also how we talked about polygon. With polygons, we talked about perimeter, right? Perimeter was the distance around the polygon. Well, there is sort of a perimeter for circles, but we call it circumference. Circumference, again, if you imagine starting somewhere, walking along the circle, walking along, la-da-la-da-da-da-da, and you get back to the point you started at, the distance traveled is the circumference of the circle. So it's like the perimeter for a circle, so to say. So that's some terminology with the circle. And here's some other terminology as well. In the course, we're going to look at semicircles a little bit. Now, what is a semicircle? Well, it's essentially half of a circle. Semi, half, right? And the way you actually form it is you do take half the circle, but the straight line boundary part of it, so to say, is the diameter. Has to be a diameter of the circle. So you can imagine having a circle, you draw a diameter, right? You get a different diameter, so to say, visually, when the endpoints are 2 points on the circle, but it passes through the center. And you can imagine taking a knife and cutting the circle along the diameter. Then you get a semicircle. And we talked about what the circumference is. Well, you can probably guess this, and probably see this, I hope, intuitively. The circumference is of a semicircle is half that of the original circle. I mean, you would expect that, right? It's a semicircle. You have half of the circle. So that's what the circumference is. And the area, we'll also get to that shortly. The area for a semicircle, it's half of that for a circle. So we'll get that. Okay, so that's what a semicircle is. It will come up a little bit. Okay. And now we just said what circumference is, right? I mean, perimeter for a polygon, those were easy to get, right? You just take the length of each line segment that makes up the polygon. Well, for circumference, it's a little bit tricky, right? You know, a circle is not made up of straight line segments. So how would you get the circumference? Well, fortunately, there's a formula for it. And it's this. The circumference of a circle with radius r, it's 2 times pi times r. I'll say what pi is in a minute. What the heck, I'll say it now. Although it's down here. Pi is actually it's a number. It's actually irrational, meaning you cannot write it as a fraction of integers, and it's not a terminating decimal. Basically, it's a long, nasty decimal, so to say. That's what pi is. It's actually programmed into most calculators. I mean, there are approximations for it, like 3.14 or 22/7, but the actual number is, how do I say this? It's not very nice, so to say. It's actually what we say is irrational. Basically, this decimal never ends, and there's no pattern to how the digits repeat. So when you have to work with circumference or area, as I'll get to shortly, you really want to use what's in your calculator. All right. But again, that's the formula for the circumference. So the distance walking around the outside of the circle, as you can see, it's just 2 times pi times the radius. If you only knew the diameter, though, well, it's a little bit simpler, although not much, I guess. Since the diameter is twice the radius, the circumference can also be written as pi times the diameter. I think if I remember in middle school, I think they had us memorize this by saying cherry pie is delicious, I think they said. And they had another one for the area, which I'll say shortly. But that's what for the circumference, it's C equals pi times D, where D again is the diameter. Now, I don't know why this says circumference, this should say area, but the area of a circle with radius r, okay, that should be area. I don't know how I missed that when I was going through these notes, but whatever. Well, that's all right. Okay, but the area of a circle, okay, with radius r, that's pi times the radius squared. I think they had us memorize this formula by saying apple pie rates second or something like that. I don't know. I don't remember exactly, but that's the area formula. Pi times the radius squared. And again, this Greek letter pi, it stands for a number which is programmed into your calculators. I mean, if you didn't have a calculator, there are approximations you can use, but since we have calculators, these approximations are not as important. So those are 2 nice formulas. So I figured it'd be good to do some examples. Suppose we have a circle, and let's say the circle has radius 3 feet. So notice the unit of length here is feet, okay? Let's find the area and the circumference of the circle. We're going to find the area and the circumference of it. Now notice these directions also. We want to write our answer in exact form and approximate form. Exact form is the answer you get before you convert it to a decimal, before you round, in other words. You know, it's the exact answer you get without any rounding. In approximate form, that's when you round. Okay, so I'm saying let A be the area of the circle, C is the circumference. We know R is the radius. Let R be the radius. This stuff I'm writing, I mean, if you don't write this stuff like on an exam or whatever, that's fine. I mean, if you have A, I'll assume it's area, I guess. But remember the formula for area, okay? It's pi times the radius squared, right? And we know what the radius is. It's 3 feet. So we get pi times 3 feet squared. Okay, so what does this become? Well, we get pi times 9 feet squared. Remember, when you're dealing with area, right, for a two-dimensional figure, your units are going to be the unit you're using for length squared. We're using feet for length, so our units for area will be square feet or feet squared. So our answer is 9 times pi square feet, feet squared. Now, to get the decimal form of this, again, you could use pi in your calculator. You would type pi in, right? And if you do that, you'll get something like this. And then you just multiply this by 9. I know the iPhone calculator has pi programmed into it. I'm assuming the Android one does as well. Okay. Now here I said to round to 2 decimal places, right? I'm using a lot more than 2 decimal places. You really only want to round at the very end. Well, no, I shouldn't say that. You only want to round to 2 decimal places at the very end. You can round before then, but you want to round to way more than 2 decimal places. So here I'm using 5. You know, the more you use, I guess the closer to the better the answer is, so to say. But you want to use at least 2 decimal places. Since I'm telling you to round to 2, you want to use at least 3, maybe more decimal places for your intermediate calculations. So the exact form would be 9 pi square feet. I think I said feet squared before. I'm sorry, it should be square feet is what I should be saying. Sorry about that. So we have 9 pi square feet. And in approximate form, we round this, right? We're rounding to 2 decimal places. Okay. So we look at the third decimal place. It's less than 5. So the 7 doesn't change. We get 28.27 square feet. That's our approximate form. So the exact form, 9 pi square feet. Approximate form, 28.27 square feet. All right. Now I will do circumference,